Welcome everyone, and today's presentation or lecture is on the lab work, giving you introduction about the lab and how you're going to build the circuits you're going to learn during the course you're taking. Since this particular presentation is relevant to numerous courses, like the kind of lab work we will do here can be very relevant to like introduction to electricity, introduction to electronics, or basic electronics title courses, or introduction to electronics, electrical and digital circuits. And similarly, wherever there is low power electronic circuits design, this particular presentation lecture is very relevant to that particular courseware. So as we emphasize during the lecture all the time, that when you're seeing a word, when you're reading any book, any material, or on the slides presented, to see the history of that word is really interesting, and it's a topic in its own, and all the students are encouraged, if they are interested in learning about the history of that particular word, like in this particular slide, one of the keywords here is circuits and breadboard. So you are encouraged to go to quality, reliable, authentic sources like Oxford, Cambridge, Britannica, to learn about the history of those words. And while I think it's a very good practice, you will get a very important information relating that how that particular word got originated and what was the reason behind that, which really helps you basically understand the reasons behind that one particular popular word or keywords. Okay, so let's carry on with this presentation. So in the lab you will be you'll be performing labs. You will be working with these particular components. As you can see here, like you have resistors. These are the values of the resistors: 1 kilo ohm, and this symbol basically used for ohm. 4.7, 10 kilo ohm. You'll be working with capacitors of these values, microfarad, that's what it stands for. You will be working with diodes, LEDs. Diodes and LEDs, basically you will learn that LEDs are basically diodes, but you'll be working with diodes, LEDs. You'll be working with batteries of 9 volt, 3 volt, 1.5 volts, 1.45 volt batteries are pretty common. Like a AA size, AAA size batteries we use very frequently at home or in offices. Most of those AA, AAA size batteries are 1.5 volt rating. We'll be working with transistors. These are NPN transistors. That's the part number of NPN. We're working with the PNP transistors. These are the part numbers for the PNP type of transistor we'll be working with. We'll be working with ICs, like inverters, the NAND ICs. You'll be using multimeter as a tool for in the lab. We will learn about that very shortly. And you'll be making your circuits on the breadboard, so that's why it's highlighted here. And we will learn that how to use the breadboard in order to make electrical, electronic, low power circuits on it. And while working with the breadboards, you need wires. So you have in your lab which you can use wires for your circuit design or prototyping of the breadboard. We have power supplies, soldering station, oscilloscopes, and other miscellaneous lab resources which will help you perform your lab assigned tasks in relation to the course you are taking. So let's go to the next slide. So this is a multimeter, and as you can see on the left hand side, this is a digital because it has digital display. On the right hand side is analog because the display is analog. These are the video links which will help you basically learn about how to use a multimeter. But when you are in the lab and if you find yourself still struggling on using a multimeter, the resources will be, the help will be available. The lab staff will help you understand how to use the multimeter. Okay, so multimeter is called multimeter, but meter means measuring. So multi means numerous, so it's a meter which measures numerous parameters. Most commonly used multimeters in lab use measures voltage, as you can see here. It can be AC or DC. It measures resistance, as you can see here for the ohm, and it measures current, as you can see on this side in this particular section. But also it can measure, anyhow. So there are battery related features, but these are the three most common features you will find in the multimeter: voltage, AC or DC, resistance, and amps. There are other meters, where you can test diodes and even transistors as well. But as I mentioned, the most commonly used multimeters use measures voltage, resistance, and amps in relating to the low power electronics, or even because as you can see here, this AC voltage can go even up to 300. So like you can measure household AC voltages using a multimeter, provided that you know how to use it. It's very, very important. Okay, so let's go to the next slide. So let's go to the next slide. So in this slide, we are going to learn basically what is the breadboard. So if you go to the Cambridge Dictionary, it says it's a wooden board that is used to cut bread on, and that's exactly how it looked. And that picture I took from Cambridge, while searching for the keyword breadboard. So historically, this is the board which looks like, and which is used to basically, for bread making purposes or bread cutting purposes. So what this board has to do with anything with electronics or electrical circuits. So historically, with the rise of electronics, so what people used to do with inventions and the need to test or design or make different prototype circuits, they used to use this kind of a breadboard to make electronic circuits. So as you can see here, if you see very carefully, so they are using screws, and these screws are why they're basically placed on the breadboard, so that they can connect different wires, because these are conducting materials. So as you can see here, so these screws are there to hold wires, okay, or connect components. So as you can see here, the resistor is connected between these two screws, and LED is connected between these two screws, and there is a wire with a switch. So there is a switch, and which is connecting. So this wire is coming to the mid side of it, and this wire from one end of the switch terminal to the screw. And here's the battery. So basically what's happening, the plus side of these it appears to be, to me it appears like maybe AA or maybe AAA size battery. So it's a 3-volt battery. The positive side is connecting to the resistor, and the resistor is connecting with the LED, and the negative side is coming to the switch. And since the switch is on, that's why you see the LED lighting, because on means this wire is connected from this screw to this screw. So there's a conduction happening here. So because of the completeness of the circuits, the current is flowing, and that's why you see the LED glowing. So that's historically people used to use these kind of boards to prototype electronic circuits. So that is what the history of the word breadboard is in relation to the courses mentioned. Okay, so let's go to the next slide. But nowadays, you know, like these are the kind of boards we use. These are all breadboards, prototyping area. You'll be most likely you'll be using this type of a breadboard in your labs. But there are breadboards which are of smaller sizes, as you can see here. You know, this is just to mention you that these are most commonly used 63 rows. This is a row, okay, as you can see here. So or 30 rows or 17 rows, or a breadboard like this, where you can connect different power and ground on this side of the breadboard. When you connect power or ground to these terminals, they are not connected by any means anywhere here on the breadboard area. So you have to bring in a wire in order to connect with a power strip. So what I mean by that, so you see on the breadboard here or here, it's pretty clearly visible. You see these red lines. You see this red line all the way? This red line means that this entire column of holes is basically they are connected together. So anywhere, for example, if you connect a wire here and there is another wire here, so those two wires, because of the internal connection, which we will discuss in the next slide, those two wires will be connected. But there is no connection between this entire column and to the next. They are totally separate. The next column is separate. The next column is connected from here all the way to here, but they are not connected in between. So very important to realize it. Horizontally, these two columns, you see, or the way it looks, you can see this as a row. These rows are not connected together, okay, but they are connected from top to bottom. Okay, so that's why this red line, wherever you see, it means this entire column or row, they are connected. Okay, so similarly case here and here, and in this case, as you can see, this red line is right on top here. Okay, so that's exactly what's happening. And this is a red line, this is a red line, so it shows. And I think I can see a blue line here as well. This is just to red means that you will be connecting a positive supply. Not necessarily that you have to connect a positive supply. You can connect ground or a negative supply, either way, but it's just to make it look nicer. Okay, Okay, now the next thing is the these internal area. Okay, so in the internal area, all these, because the way it's, I'm going to do, call this as a column. So all these columns are connected. Okay, but this column is not connected with this column. Okay, because as you can see here, there is a notch, there is a separation in the right in the mid. So most of the time there are 5 holes on these type of breadboards. 5 holes on the right hand side, 5 holes on the left hand side, or top or bottom, you say. So these all holes are connected together, but they don't have a connection horizontally here. Okay, so understand it very clearly, please, here, that this column, they're all connected underneath. So if you connect a wire here, anywhere else you will connect a wire here, those 2 wire connections will be connected together. Okay, so this column has no connection with this column because of this notch area. So but from this hole right to the bottom, they're all connected. So this is a similar thing will with every you say the row is the same. So they are connected internally, but they are not so the way it looks, they are connected vertically but not horizontally. And over here, this entire big red line means that the entire holes they are connected horizontally but not vertically. Okay, so in this particular case, again the same thing, you know, the big line means that the entire row is connected. Again, this big red line, it means the entire column of holes are connected, but they are not connected in between. Okay, so the middle area, the right hand side of the notch, the holes are connected, and the left side of the holes in the row, they are connected, but they are not connected vertically. Okay, so as you practice, you will learn more about it, and so these are the most commonly used breadboards, but there are you know, labs which use these kind of breadboarding prototyping area. And the reason behind that, as you can see, they have power supplies and other, you know, numerous features on this particular kind of setup, which really helps quickly do the prototyping. So let's go to the next slide. And as you can see here, before going to the next slide, so it's basically a power rail. So you can see that I'm just flipping this this breadboard 90-degree clockwise. So as I was mentioning, so these are we use for the power rail because the holes are connected between, and this is for the ground rail. Doesn't matter, you can put your ground here, or you know, but the coloring scheme really helps. It's a good prototyping practice to follow red for the power and black or blue for the ground, and this is for the circuit area. And these lines, as you can see here, so it means these holes are connected, the green, okay, on the left, but they are not connected in between because of this particular spacing in between. So similarly on the right hand side. Let's go to the next slide. So so we have learned in the last slide that how the breadboard connections are connected in between. I think it really helps to see how it is manufactured underneath. Now, this is the top area, the top look and feel. If we remove the top, this is what we see underneath. So underneath, as you can, it uses these type of metal strips. Okay, so these metal strips are connected here, and as you can see from this strip that it's so like 1 2 3 4 5, and as you can see here 1 2 3 4 5. So this one metal strip is underneath here. It's one metal piece with holes, and why you have to press when you're trying to insert a wire or a component leg in here, why you feel a force, because as you can see on the top, it's deliberately designed this way so that when you gently press, it will hold and it won't be a loose connection because of the way this metal strip has been designed. Okay, so you have all the metal strip on this side, and on this side it's a one big piece which you will see in here, maybe on the next slide. But this metal strip is made of stainless steel or steel with nickel platinum, bronze or bronze variations, or copper and copper variations, or alloys. So it has to be kind of a conducting material, and every material has its own properties. So depending on what the manufacturer can find, you know, that they will place underneath these to manufacture the breadboard. Okay, so let's go to the next slide. So as I mentioned here, I showed you these metal strips. Okay, so they are placed horizontally on the breadboarding area, and on these power strip columns, so you will, you know, underneath it's a big metal strip. That's why the entire column is connected, the holes are connected underneath. So you will find one metal strip underneath this column, another metal strip under this column. Similarly the case as you can see here. So there are two long metal strips for the power connections, ground and positive or negative supply. Okay, so let's go to the next slide. So now let's talk about how we're going to build a circuit on a breadboard. So on the right hand side you can see that we have a circuit, and that's how we start. That we've been given a circuit, or we want to try out a circuit, and we basically either by hand or using a tool lay out the schematic. So any circuit like this, we call it as a schematic, and in the schematic we want to make sure that the connections are right. As you can see here, the purpose of this circuit is to simply turn on the LED and make it glow when this switch is connected. And why is that? As you can see here, the plus side is connected with the plus side. This rectangular area with the black color for our diode is called the anode side, or the plus side of the diode, which is connected to the plus side of the battery, with a resistor to limit the current. It can have, you know, any value, 50, 100, or even 1K, it doesn't matter. So to limit the current, and so once this switch is closed, it completes the circuit, the current flows, and because the plus is connected to the plus and the negative eventually will come to the negative of the battery, the diode will glow, and that's the purpose of this particular circuit. So this battery, if you are making this circuit in the lab, you can find a 5-volt battery and you can connect it, or if you couldn't find a power supply, you can use 3 AA or AAA size cells in order to make it a 4.5 volts and to make it work still the same. Or you can use even 2 AA or AAA size batteries. So in order to make this circuit, we need components, right? So we have a resistor. So assume that this is a 40 ohm resistor. Don't go to color coding. I'm just putting a picture here. And we need an LED. And why I'm showing you these components, because these components have legs. So resistor has 2 legs. Okay, it's an axial resistor. Similarly, an LED has 2 legs. The longer leg is a positive side, and the shorter leg is a negative side. So that's how the LED looks, and that's what we really use. Then we have this switch, and this switch, which you can buy from DigiKey or any other, or you can find it inside the lab, has 4 legs. And if you click on these pictures, like for example, as you can see this hand, if you click on this picture, it will take you to the data sheet. And if you read the data sheet, inside the data sheet, this is what the schematic of this switch you will find. So what it's showing you, that the side 1 and 2 are connected together. So it means these 2 legs are connected together, and then 3 and 4 are connected. So similarly on the other side, 3 and 4 are connected together. Once you press the button, this switch closes. So when the switch closes, all these lugs get connected. So what it means is that when you're putting this switch on the breadboard, you want to make sure that how the legs configuration look like, so that you can make a proper connection as shown in this particular schematic. And for the batteries, assuming that you don't have a power supply, so you can use these battery holders. You can find it again from DigiKey, Amazon, or eBay, and you just use this is the AA size, this is the triple size cell. You place this inside the battery holder and have it connected in the circuit, because as you can see here, it has red for the positive side and black for the negative. You can easily plug in these connections on your breadboard. Another important thing, maybe the students want, it's important for them to introduce you, that when you hold a cell, one side you will see a notch. This is the positive side of the cell. They're very important for you to understand that. The flat side of the cell is the negative side. So when you are placing the cell or the battery inside this battery holder, the flat side will go towards the spring. Okay, that's the negative side, and the plus side will come on the other side. So I hope that it will be useful for students, or working with the batteries to make circuits for the first time. So let's go to the or as mentioned here, you can find these power supplies inside the lab, and red means plus side, negative means most of the time is black, but on some power supplies you will see the yellow side as well. The yellow means is the negative voltage. Okay, like here you can see here, and similarly here I think it has a negative, because it has 3 terminals as you can see here. So it has a negative voltage side, as well. So it means that most of the time we'll be only working with plus and ground. Okay. And in order to if you need to buy parts, these are the three very quality sources you can find parts from. DigiKey is very established in North America, and they are very kind of when it comes to delivery and quality, they are very well, as I mentioned, recognized in the engineering and scientific community relating to finding parts. Amazon is another good source. A lot of people sell electronic parts on Amazon or even eBay as well. So these are the three quality resources from where you can find the parts mentioned on this particular slide in order to make and test your circuits. Okay, so now we have the parts. We understood that what we are doing. So let's try to make the circuit. Okay, so what we're going to do, the first thing what I recommend, that you place your components and then in the last carefully place or connect your power supply. Okay, do not connect your power supply right at the beginning. So it's an advice, recommendation. It will really help. Okay, so no connection on plus 5 volt or 4.5 volts depending on what you're using, or ground. So leave them as is. So let's connect the LED or the diode. So these are just two configurations of the same circuit. So let's talk about this configuration. So as you can see here, I'm connecting the plus side. Why they're connected like this? Because we know that these all holes in a row are connected together. So I'm placing the LED one leg on this side and the negative side on this side. Okay, so the plus side is here of the LED, the longer leg, and the shorter leg, the negative side, is this one. Okay, and they are not connected in between because the rows on a breadboard, they are not connected together. Okay, so I place the LED. Okay, now I take a small piece of wire, stripped, a gentle one. Then I place the one end of the wire on the same row where the positive leg is connected, and place it to the power strip where I have my intentions to connect the plus 5 volt, even though the plus 5 volt I am not connecting at this moment. So there is no wire here. Okay, so I connect it here. Now I go to the negative side, and there is a resistor of 40 ohm, or most of the time we just put an R. It means it's a 40 ohm resistor. So I put a resistor, and as you can see here, one side of the resistor, or the one leg, is connecting the LED negative side. The other side is, after this spacing, goes to the other side of the breadboard. So it means these two resistor legs are not connected together, and that's exactly what we want. So we have one end connected to the LED's negative, and the other end is available here. So here I placed my switch. Assume that this is 1 and 2, and this is 3 and 4. So these switch legs are already connected, so placing them in the row is all perfectly fine. And 3 and 4 are connected together, and placing them on a breadboard single row is perfectly fine. And here I took the blue wire and I connect to the negative where I have my intentions to connect the negative power supply. So I place it into that power strip. Okay. So I connected my LED, I connected the resistor, I connected the switch, and after making all these connections, I want to revisit to make sure that all the connections are fine. So I revisit plus here, negative, the resistor, switch, side 1 and 2, let's say this is 3 and 4, and the switch side, the other side of the switch is connected to the negative rail. Now, after making sure that my connection is right, I will connect my plus 5, the battery, the plus terminal of the battery or the power supply, using this wire here, and the negative side, which is the ground, I will connect here. Once I do that, and if the connections are right as mentioned, then the LED will glow. So and that's exactly another variation of the same circuit. And here what we are doing, we're just placing this switch in the mid. So assume like this is 1, 2, and this is 3, 4. Again, doesn't matter even if they're connected or not. But the thing is, the plus side, as you can see here, this is the plus side of the LEDs coming to the plus supply voltage, where we will be connecting the plus 5 volts. The negative is connected to the resistor, and the resistor leg is coming to one of the switch terminal. 1, 2, or 3, 4, doesn't matter, even though these are not connected, but that doesn't matter, because once you press this button, all these lugs are connected, so it means this will connect here as well. And the negative side, one of the terminal of the switch, we are connecting to the negative power supply. Again, another configuration, and when you press the switch in this configuration as well, you will see the LED glow. So let's move to the next slide. So let's build another circuit, and in this particular circuit we are going to use an IC. So a component which looks like this, we call it as IC. IC stands for integrated circuit, and this is the IC 4011, which is a NAND gate IC. And NAND is a digital gate with a symbol like this. And as we learn about this gate during the course, you will see that how it works, what it is truth table, so on and so forth. But the important thing before building this circuit, I want all the students to know that NAND is the gate which one can use to build any digital logic circuit or equation. So you can make any digital logic circuit or digital equation, same word, same meaning, same concept, by simply using NAND gates. And that is one of the key feature of this particular gate. So let's learn about it. If you click on this particular picture, as you can see the hand, it will open up the data sheet, and this is a snapshot taken from the 4011 IC data sheet. So as you can see here, it has 14 legs. So let's count it: 1, 2, 3, 4, 5, 6, 7. 7 times 2, 14. So it has 14 legs, and it has 4 NAND gates. So 1, 2, 3, and 4. And these are the inputs: A and B inputs, 3 is an output. In this case, 5 and 6 is an input, 4 is an output. So again, so on and so forth. Pin 7 is VSS, stands for ground. So pin 7 we will connect the ground of the power supply, and pin 14 is VDD, stands for we will connect the positive voltage, positive supply voltage on pin 14. Okay, so what circuit we want to build? So let's learn about the circuit. So the circuit shown in this particular schematic, we are simply making an AND gate. So this is a NAND gate. Okay, an AND gate has a symbol without this circle. This circle in a digital world is meant for inversion. Okay, so if we remove this circle, the symbol of an AND gate will look like, say, circle means that the output is inverted, and so we are going to use the NAND gate to make an AND gate. So as you can see here, we are using an AND gate, and we're simply inverting. So another NAND gate we are using as an inverter. As you can see here, because pin 5 and 6 are shorted, connected together, so the behavior of this entire NAND gate will be simply to invert whatever it gets from this particular NAND as an output. So one inversion, second inversions cancel out, and that's these two gates will make an AND gate. So let's build this circuit. So we place the IC. As you see, we have one legs of the IC on one side of the breadboard, where the notch is or where the gap is, and the other the legs on the other side, so that they are not connected, because we cannot place an IC on the left side of this breadboard or the right side, because they will get shorted, and that's exactly what we don't want to damage the IC. Okay, so this notch is basically there to provide that separation, so that we can easily place components like integrated circuits or switch or anything like similar on this particular breadboards. Okay, so again, do not connect your power supply in the beginning, just make the connections. So 14 is for the power supply, so we are using this strip for the power supply. 7 is for the ground, and we are using this column or a strip, power strip, for connecting the grounds. Pin 1 and 2, so as you can see here, this is pin 1, it's coming out as a wire. Pin 2 coming out as a wire. Here we will provide the inputs. We are connecting pin 3 with pin 5. As you can see here, 5 and 6 are shorted. As you can see, 5 and 6 are shorted. 5 and 6 is an input, and we are connecting the output 3 to 5, which basically, so we can connect it to 5 or 6, doesn't matter, but over here we are connecting it to 5. And 4 is an output which goes to a resistor. As you can see here, is connecting with one end of the resistor, and the other end of the resistor is connecting with the positive side. As you can see here, this even the longer leg has the indication that it's the positive side, but some LEDs do have these notches, because we do cut the legs to make it equal, for numerous purposes. But still, you can find out from this little curve that which side is the positive side of the LED. So we're connecting the positive side with the other end of the resistor, and the negative side goes to the ground. And as you can see, the LEDs, in different rows. Both the legs are on a different row. You can connect, have the other leg, at any other row. the way you want to connect. Okay, and once you make these connections, reconfirm your connections, and then connect the supplies, give it the input. So the logic works like that for the NAND gate, that both inputs has to be any input 0 gives you a 1 at the output. Okay, so any of the inputs 1 or 2 having 0 gives you 1 at the output. So if you have 1 here, it gets inverted, means flip is it goes to 0. So in order 0 means the LED won't glow. So in order for you to glow the LED, you need 0 here. So 0 here means you get a 1 and the LED, the current will pass and the LED will glow. So how you get a 1 here? To make both of them as 0, because once you have oh, I am sorry for that, to have both of those as 1. So once you have both pin 1 and 2 as 1, you will get a 0 at the output here, and 0 means you will get 1 here, and the current will flow and the LED will glow. Okay. Okay, so let's discuss some more about wires you will find, or you can potentially find inside the lab or the working environment. These are the most common spools found inside the labs, where you just basically pull out the wire to this required length, then you strip off the ends and use it on the breadboarding. And as you can see here, as a it's highly recommended to use red for when you're connecting the power supply or the power lines, blue or black when you're using the grounds, and you can use any other color for your breadboard connections. But as a common good practice, we use black for the ground, red for the power, and blue or green, or even sometimes yellow for the conventional digital connections. Or you can find these pre-stripped, nicely cut, different size of breadboard wires. We'll just simply pick up the size you need, and you can just place some of the wires. Pretty quick, but it's good for the lab practice, but it's recommended to get used to using the tools by cutting and stripping off. That really helps, because most of the time this you can find inside the educational institutes, universities, colleges, but in a working environment, this is the most common kind of a thing that you will find inside their working environments. Again, you can also buy prototyping wires, or wires like this coming in batches in different sizes and lengths. It has pins on either side, so you just simply strip off the wire you need and just place it on your breadboard for prototyping. In all of these three, for students to get a really I'll say quality skills, and to be ready in almost any working scenario, it's recommended to use the tools, the cutter to cut the wires, and stripper to strip off the ends, because these are already pre-made. There is you just have to place it onto the breadboard or the prototyping area. where these spools will really give you the skills required in order to be ready for even in I'll say conventional working environments. So these are some good examples of breadboarding, and as you can see here, how nicely the resistor legs are cut, placed, how nicely the wires are cut, placed, the color of the selection of the wires. So this is a very good example of breadboarding. And similarly, as you can see on this side of, and see the curves, you know, that's really this not only looks nice but also really helps efficiently troubleshoot in case of any issues with your circuit or design. So these are basically the desired and clean breadboarding circuit examples. And these are some of the undesired breadboard prototype circuit examples. You don't want to do breadboarding like this or this. This or even I'll say this, because you know so these are basically undesired breadboard prototyping examples. Whenever you're using a breadboard, highly recommend it to make it clean, look nice, because anyone else seeing your work will evaluate you on what you have done and how you do your things. Okay, so these are the references from where I have taken the pictures or resources I showed you on this particular slide. So thanks very much for attending this presentation and hearing. Looking forward for the next lecture. Take care.